Alright, so I want to start off by just drawing a quick free body diagram of the block on the table surface. And of course the forces acting on the block included mg down, the normal force of the table on the block up, the pulling force, we'll call that tension, that we applied to the block, and then of course the friction force that opposed that motion that was in the opposite direction. And of course what we did was we very different variables to see which ones were affecting the magnitude of the friction force. And the way we recognized what the friction force was, if we can manage to pull the brick at a constant velocity, then we know that the forces in the horizontal direction are balanced, and therefore F net in the y direction is 0, or excuse me, in the x direction is 0, which is T minus friction, and therefore the tension force that we're pulling with is equal to the friction force if we can pull it at a constant velocity. And then of course, since it's not leaving the tabletop, we know that the normal force will be equal to mg, because the F net in the y direction is also 0, and it equals n minus mg. Therefore, n equals mg. And then we use these two net force statements to conduct our experiment. By reading the value of the spring scale, which was our tension force, we were able to determine the friction force, and by varying the amount of mass on top of the brick, or on top of the block, we were able to measure the mg force, which then gave us the normal force. And hopefully you determined that the factors that actually affected the magnitude of the friction force were that normal force, as well as the two surfaces that were in contact. And of course we varied that by using the lab table, the student tables, the marker board, and the floor. Now, if you were to graph your pulling force as a function of time, what you would recognize is, and you probably noticed this, as you pulled on the spring scale's reading gradually got greater while the block was not moving. And then as soon as it began to move, it dropped off and kept a constant value if you were able to pull at a constant rate. And we discussed that we can break these two types of friction down into two groups. Before the block was moving relative to the table, we call that static friction because the two surfaces are not moving relative to each other. And then after it starts moving, we call that kinetic friction because the two surfaces are moving or sliding relative to each other. Notice a couple of things. First of all, notice that the maximum value for the static friction when it started to move was larger than the kinetic friction. And then also notice that the kinetic friction stayed the same regardless of how fast you pulled it, so long as you pulled it at a constant speed.